Welcome to the channel Maths for Graduates. Today we'll see the proof of Cauchy's theorem. So let's start. A statement of this theorem is, suppose f of z equals to u plus iota v is a complex function which is analytic in a simple connected domain D, then for every simple closed contour C in D, the integral of function f of z in contour C is always 0. Okay, in the previous video we have discussed the concept of analyticity, simple connected domain and contours. So now let's come to the proof of this theorem. Okay, so integration f of z dz is integration c, f of z is u plus iota v and dz will be dx plus iota dy. Okay, now let's separate real and imaginary part. Okay, so after separating we'll get integration u dx minus v dy plus iota integration c v dx plus u dy. Okay, now using Green's theorem, this line integral changes into double integral. Okay, so applying Green's theorem, so we'll have double integration in region R. This will be minus del v over del x minus del u over del y dx dy plus iota double integration in region R del u over del x minus del v over del y dx dy. Okay, since it is given that function is analytic, so it will satisfy Cauchy-Riemann equation. Okay, so from Cauchy-Riemann equation, del u over del x, this will be del v over del y, and del u over del y, this will be minus del v over del x. Okay, so using Cauchy-Riemann equation, this will be 0 and this will be 0. Okay, hence given integral will be 0. Okay, so integration of function f of z in contour C is 0. Okay, I hope proof of this theorem is clear to you. Now let's see some problems based on this concept. So we have a question here, integrate in contour C of function z square plus 1 over z minus 4 dz. Okay, and contour C is unit circle. Okay, so this given function f of z, this function f of z, z square over z minus 4 is analytic everywhere except at z equals to 4. Okay, so we have this is unit circle and suppose z equals to 4 is point somewhere here. Okay, so you can see this function f of z is analytic inside this circle mod z equals to 1. Hence using Cauchy's theorem, integral of z square over z minus 4, this will be 0. Okay, now let's see another question. Integrate tan z dz in contour C, and C is again unit circle. Okay, so we have function f of z is tan z. Okay, we can also write this as sin z over cos z. Okay, and this function is not analytic when denominator is 0, that is cos z is 0. Okay, so from here z will be 2n plus 1 pi by 2. Okay, and n is integer. Okay, so this function is not analytic at z equals to plus minus pi by 2, plus minus 3 pi by 2, and plus minus 5 pi by 2, and so on. Okay, so let's point these points on Argand plane. So this is x axis, this is y axis, and these points are here. This is pi by 2 and this is minus pi by 2, this is 3 pi by 2 and this is minus 3 pi by 2, and in the same manner it goes on. And unit circle is this. So you can see this function tan z is analytic inside this circle, hence integration of function tan z in this circle C is 0 using Cauchy's theorem. Okay, now this video ends here, and I have a quick announcement to make. Those students who are preparing for exams like CSR Net, GATE and other MSc entrance examination can buy complex analysis handwritten notes for a very reasonable price for only ₹50. This note contains lots of problem and concepts. So if you are interested, you can contact us through this WhatsApp number. Thank you. Thanks for watching.